So far we have seen some important properties related to atoms like their electronic configuration, atomic number, mass number, etc. We'll now see some other important properties like valency and octet rule. Let's see what they are. The outermost shell of an atom is known as its valence shell, and all the electrons that are present in this shell are known as valence electrons. So for any atom, say in this case, this atom has 2 shells. So the second shell is its valence shell. It has 4 electrons. So these electrons are known as its valence electrons. Similarly, this atom has 3 shells. So the third shell, which is the outermost shell, is known as its valence shell. And this has only 1 electron in the valence shell. So this 1 electron is known as its valence electron. An atom X has electronic configuration 2881. The number of valence electrons in the atom X is equal to, we know that the valence electrons are the number of electrons which are present in the outermost shell or the valence shell. This electronic configuration means 2 electrons are present in the K shell, 8 in the L shell, again 8 in the M shell, and 1 in the N shell. So the N shell is the outermost shell of this atom X. The outermost shell has 1 electron. So the number of valence electrons in the atom X is equal to 1, as seen from the electronic configuration. 8 electrons in the valence shell is the most stable arrangement of an atom. This is known as the octet rule. It holds for all atoms. Whenever any atom has 8 electrons in the valence shell, that is the most stable arrangement for that particular atom. So let's see these cases. So all these atoms, they have 8 electrons in the valence shell. This atom helium, it only has 2 electrons. So when it occupies these 2 electrons, this system is known as a duplet. And even this is a stable configuration. So for all the remaining atoms, whenever there are 8 electrons in the outermost shell, this arrangement is known as octet. And it is observed that noble gases are those elements that usually follow this system of octet. That is, all the noble gases, neon, argon, krypton, xenon, radon, they all have 8 electrons in the valence shell. The only exception is helium, as it follows a duplet. So the noble gases, they have 8 electrons in the valence shell. These are also known as inert gases. Because we know, whenever any atom has 8 electrons in the valence shell, that is the most stable arrangement for that atom. So all these noble gases, they have 8 electrons in the valence shell. That is, they have the most stable configuration. So they do not participate in chemical reactions. And that is why they are known as inert gases. So all atoms, they try to achieve this noble gas configuration to become stable. For example, sodium. It has the electronic configuration 281. Now to gain stability, that is to follow the octet rule, it can either gain 7 electrons, by that it will have the electronic configuration 288, or it can lose this electron, so it will have the electronic configuration 28. Gaining 7 electrons is very difficult as compared to losing 1 electron. So it prefers to lose this electron, and that is why it tries to attain the nearest noble gas configuration of neon, which has the configuration 28. Similarly, chlorine has an electronic configuration 287. Now, it can either lose these 7 electrons or it can gain 1 electron. Again, losing 7 electrons is very difficult as compared to gaining 1 electron. That is why it tries to attain the noble gas configuration of argon, which has the configuration 288. So it tries to gain 1 extra electron. So we have sodium, which has 1 extra electron in the valence shell, and we have chlorine. It is 1 short of electron. So this sodium, it gives the extra electron to chlorine. By doing that, now sodium has the electronic configuration 2,8, chlorine has the electronic configuration 2,8,8. Both of them satisfy the octet rule, and so both gain stability. So this is how atoms gain stability, by losing and receiving electrons. Let's take another example. Here we have a magnesium atom. It has an electronic configuration 2,8,2. Now it has 2 extra electrons. To gain stability or to follow the octet rule, it can either gain 6 electrons or it can lose 2 electrons. We know gaining 6 electrons is not easy. So it tries to lose these 2 electrons. Each chlorine atom is short of 1 electron. So it gives 1 electron to this chlorine atom and it gives 1 electron to this chlorine atom. By doing that, it gets an electronic configuration 2,8. Each chlorine atom gets an electronic configuration 2,8,8, and hence all of them are stabilized. So atoms, in this case, one species or one atom gives electrons, another species or another atom, they receive electrons, and by doing them, both are happy. This is a case, say 2 people are sitting on a boat. One of them has extra number of balls, that is more number of balls as compared to the other person. Suppose the boat starts sinking. So they panic. So by passing one extra ball to the other person, they prevented the boat from sinking. So one person was happy because he gave away the extra ball, and the other person was happy because he received the extra ball, and hence the boat did not sink. This is the same case as in atoms. To gain stability, sometimes atoms lose electrons and sometimes they gain electrons. And by doing that, they become stabilized or happy. But gaining or losing electrons is not always the case. For example, carbon. It has 4 electrons in the valence shell. Now to gain stability, it can either lose these 4 electrons or gain 4 electrons. But it's not easy to do that. So what it does is, it shares electrons with hydrogen. Each hydrogen atom has 1 valence electron. So when 4 hydrogen atoms, they come together, so each hydrogen atom shares 1 electron with carbon. In doing so, each hydrogen atom attains the duplet structure. And each carbon, in this case only 1 carbon atom, so it gains 8 electrons in the valence shell, and that is why it satisfies the octet rule. So in this case, by sharing electrons, the carbon and hydrogen, they are able to complete their octet and duplet structures, and hence both are stabilized. This is a case, say one person has a bat, another person has a ball. Can they play cricket on their own? No, it's only when they decide to share the ball and the bat that they have, only then can they play cricket. So by sharing, both are happy. Similarly, in some cases, when atoms have 4 electrons in the valence shell, they do not gain or lose electrons. Instead, they share electrons. And by sharing electrons, they are stabilized. So the term valency is defined as the number of electrons gained, lost or shared, so as to make the octet of electrons in the outermost shell. So let's see the valency for a few atoms which have these number of valence electrons. So whenever any atom has 1 valence electron, we know it can easily lose 1 electron. So it has a valency plus 1, or it can also be written as simply 1. When an atom has 2 valence electrons, again it can easily lose these 2 electrons. So it has a valency plus 2 or simply 2. Similarly, when it has 3 valence electrons, it has a valency plus 3 or 3. When any atom has 5 valence electrons, it's not very easy to give away these 5 electrons. Instead, it tries to gain 3 electrons. So by gaining 3 electrons, its valency becomes minus 3. That is, it gains 3 electrons. So now it has 3 extra negative charges, and that is why we get minus 3. Or it can be simply 3 Similarly, when it has 6 valence electrons, it can gain 2 electrons. In case an atom has 7 valence electrons, it gains 1 electron. Whenever any atom has 4 electrons in the valence shell, it neither loses nor gains 4 electrons. Instead, it shares electrons. So by sharing 4 electrons, it gains stability. So this is how we get valency. That is, when atoms lose, gain or share electrons, the number of electrons that are involved is known as the valency. Chemically active elements have an incomplete octet. We know noble gases do not participate in chemical reactions. That is why they are known as inert gases. And also they have complete octet. The reason for this stability is their complete octet. So whenever any element does not have a complete octet, that is, it has an incomplete octet, it takes part in chemical reactions to gain stability. And by taking part in chemical reactions, it becomes chemically active. Why do atoms combine? We know in life everyone tries to attain stability. So is the case with atoms. They combine to attain stability. That is, they combine to attain the electronic configuration of the nearest noble gas. Noble gases, we know, are very stable because they have complete octet. So when atoms combine, they try to attain the electronic configuration of the nearest noble gas, and hence they attain stability. Why are only electrons transferred from one atom to another? When we talk of valency, we say it's the number of electrons gained, shared or lost. Why aren't we saying that it's the number of protons or neutrons? Why we only talk in terms of electrons? This is because this is the structure of an atom. The protons and neutrons, they are tightly bound in the nucleus of the atom. The electrons are freely revolving in the shells or the orbits of the atom. That is why the electrons can be lost, gained or shared. But these protons or neutrons, which are tightly bound in the nucleus, cannot take part in the reactions. That is why only electrons participate in chemical reactions.